Hello and welcome to this tutorial on using Vuforia to calibrate a HoloLens scene to a real-world space. Vuforia is a plugin. It's a third-party plugin made by, well, it used to be Qualcomm. Now it's called PTC or PCT or something like that. Anyway, it uses image tracking. So you also learn how to use image tracking with the HoloLens today if you don't already know how to do that. So the first thing we're going to do today is go ahead and show you what the end result is going to be. So I'm going to do that right now with the HoloLens. So what's happening here is I have my office space that I've scanned and I want to put a cube on my desk over here. So I have this target up on the door and this acts like a calibration target. So anytime my 3D graphics get mixed up or not quite calibrated to the room from my Unity project, I can just look up at this and pay attention until these green lines line back up with this image target. And all I'm doing in this app very simply is putting a cube on my desk, and that's it. You know, you could of course go just completely crazy with what you want to do, but this is like a little Hello World app. And yeah, I have a target on my desk there, so let's do this again. So recalibrate, and there's the cube. So now if I look at the wrong calibration target, then the cube's around here floating uncalibrated up there, so it thinks my desk is up there. So again, calibration, cube. Well, let's give it a little bit more time. There's the cube. So that's what we're going to do today. It's quite actually an involved process. I'm going to assume that you have a Unity project, or maybe you're making one from the ground up. So I'm going to make one from the ground up, and if you already have one made, just bear with me here while I make mine or fast forward. So I'm using Unity 5.6.2 F1. So I'm going to make a new project and call this HL Vuforia Calibration, and that's fine. 3D graphics, create project. Okay, so the first thing I always do when I open up a brand new project is just save out my scene, just so I don't have to constantly hit Control S by default or by my own habit and have it pop up with this window. So I'm just going to title this calibration example. Okay, and then actually on the bottom of this video is a Unity package that I made. So in the description of this video, go below and hit like more info, and there should be a link in there to give you this Unity package that I made to help you kind of do this. So I've already got it on my system in the downloads folder. So okay, so in your downloads folder you should have the Vuforia HoloLens calibration tool.unity package, and I'm going to import that by just going to Assets, Import Package, Custom Package, going to Downloads, and there it is, Vuforia. Yeah, you got it. Open, and all that's coming in is a folder and with some folders within with assets, and then there's this extra added thing called the recalibrate target.jpg. So I'm going to import that. Alright, so that's in there. And there should be a folder now in your projects called AR Calibration. Now within that, we need to print out, like actually on a real printer, a paper target to use with this calibration. So go ahead and go in that folder, and I made a target in there called Recalibrate Target. We're not actually going to use this in our Unity project, it's just there for us to print out. So I'm going to right click on that, say Show in Explorer. Okay, and then you'll find it right there. When I bring it up in the window, it looks like this. There's actually a black border around it, but Windows Picture Viewer doesn't show that. And then to print it, I'm just going to hit Control P, and there it is there. Now, the important thing here is just to not scale it. So if your printer settings have anything to do with scale, just try to keep the original scale. Luckily, mine didn't. So I'm going to hit Cancel. I already printed it out. So I'm going to go back to the HoloLens here so you guys can see something. So okay, so I have my target printed out here, and it's important that it's the right scale to meet the real world scale. So I've just got a tape measure here, and I'm just measuring the top border. It should be 6 1/4 inches, and this one is, so this is printed at the correct scale. If yours is not, double check that your print settings are set so that it's not stretching your image up or down, and reprint it so that you actually get this to meet 6 inches, 6.25 inches. Okay, and that's it. Let's get back to Unity. So now we've got to import the Vuforia stuff, and Vuforia is a third-party plugin, and it's unfortunately not on the asset store. So we've got to go out to a website. So I've got Chrome up here. I'm going to go to developer.vuforia.com. Okay, so then once you're here, you're going to want to log in with an account. So if you don't already have an account, make one for Vuforia. It's pretty important to have that because you can't really do it without it. So then I'm going to log in. Okay, and then the first thing you have to do once you're on this page is it's kind of weird where you go to pricing. We're not actually going to pay anything. We're going to do a developer version of this, so there's not really much difference. You can go through these and see if you want, but you get most all the support, or at least a taste of all the support trialing of everything, and it puts a little watermark in the bottom right hand corner of your HoloLens, but you don't see it because it's not within the field of view, so it's not a big deal. So you go to get license key, and we're going to choose development, and then our app name is going to be called Vuforia HoloLens Calibration, and then that's fine. You can call it actually your real app name, it doesn't matter. You say next, so it doesn't charge you for this because you're just in development, and then you have to accept by confirming, and then it creates this license. Now I've got a bunch of here, and if this is the first time for you, then this will be the first time you actually see these. So just pick your project here by clicking on it right there, and you'll get this license key right here. And go ahead and just put that in your clipboard by highlighting that whole thing, right-clicking, and say copy. You can come back and get this later if you need to, like if you accidentally copy something else. But now we need to go to downloads, and in downloads you're looking for the download for Unity Vuforia plugin. So agree to that and download that. That's a Unity package once again, just like the one I provided. So we go back into our Unity editor here, right click on our assets folder and go to import package, custom package, or you can do it the same way I showed you earlier, assets, import package, custom package. I'm assuming you're a novice Unity user here, so I'm going to try not to cover too many basic points like that. Alright, so mine's here, so I'm going to open that. This one takes quite a while to import. It's a lot of assets, a lot of scripts, a lot of tiny files. So as soon as I hit import here, I might fast forward the video and let it sit here and chug. So if you're using a newer version of Unity than they've last released Vuforia with, it usually works fine. I think they last tested it with 5.5. Check the release notes when you download it if you really want to match the version, but otherwise you can just say this, I made a backup, go ahead. I'm at, like I said, in Unity 5.6.2, and it's working perfectly fine for me. Okay, so it takes quite a bit of time to import, but then once it's in, you get a plugins, resources, and Vuforia folder. So you want to go to Vuforia, and there's a folder in there called prefabs, so open that up. And then we're going to grab two of these prefabs. So we want the AR camera, and don't drag this out into your scene arbitrarily. Drag this to your hierarchy, and then drag the image target into your hierarchy as well. And the first one we're going to mess with is the AR camera. So we're going to select the AR camera and then go to on the right here in the inspector, open Vuforia configuration, and you see this big empty field for app license key. That's the key that we copied earlier, so I'm going to hit Control V. If you don't have this copied still, just go back to the Vuforia page, go back to develop, and then find your actual project here somewhere, and then select it, and then you should be able to get the key off there. Okay, so this is actually like something that has to go out to the web and authenticate just so you have it. So that's kind of annoying, but you can do an offline mode. Look into the Vuforia documentation so that you can get that as well if you don't want to connect your HoloLens to the web for some reason. Okay, coming down below here, we also have to set this to a digital eyewear solution. So I'm going to hit this drop down, go to optical see-through, and then this drop down here, go to HoloLens, and that's pretty much it. We can't use our webcam in this stuff. Typically, if you use Vuforia in the past, you could actually hit play in Unity and use your webcam on your computer to see if things are working. Unfortunately, the iteration loop for this is you have to compile it to the HoloLens and test it on the HoloLens. Or I suppose you could use a HoloLens emulator, but I'm not sure that works with Vuforia. So I guess don't try that. Alright, anyway, now going back, the next thing we need to do is set up our target. Okay, so the image target right now is predefined with no, we have no databases to hook up to. And the database is actually just this picture that I had you print out. So we're going to go back to the Vuforia website, okay, and we're going to build a target. So you want to go to Develop, Target Manager, and then we're going to add a database, and then we're going to name this Calibration Target, okay, and then this is a device type recognition, not cloud or ViewMark. These are two special types of image targets you can create using Vuforia. I haven't tested either of those with the HoloLens. Alright, we're going to create that. And then within that, you're going to find, again, it listed somewhere down below here. So I named it Calibration. Here it is here. And there's nothing in there, so we need to add a target. So the way I do that is select that, and then we have to browse for it. So go to your Unity project. Okay, so I'm in my Unity project and I'm navigating to Assets, AR Calibration, and you want to find that Recalibrate Target. So again, this is the thing you brought in, the picture you printed off. That's what you're pointing into this part here. So you say Open, and this width measurement, since we're matching to the real world, it's really important that we get it right. And Unity is in meters. Oops, yeah, Unity is in meters. So and then our target is 6.25 inches in width to meters. So I'm doing just a conversion with a Google search here. So we have 6.25 turns into 0.15875. So I'm just going to copy that, put it in here. Okay, and then we name it whatever it wants, whatever it's named here, or you can change that, it doesn't matter. And then you hit add, and then it uses a cloud service to actually generate a database from that image. Okay, so it says processing right now. Typically these things are almost instantaneous. So if I refresh the page and hit continue, you can see that we got a 5-star rating. So that means it's going to track really well from the HoloLens's camera. And then when I select it, and then down here it says show features, you can see all these like little yellow plus signs. These are all the points that are going to be easy for the HoloLens to see it with, and that means it's actually a really good target to use. Okay, going back to Target Manager, Calibration Target, we're just going to check this checkbox right next to it and hit Download Databases. And then we're choosing this for the Unity editor, so choose that and say Download. It's going to package it for us as a Unity package, so this is our third Unity package we're importing the same way. Now, don't you worry if you're using Vuforia in your project somewhere else and you're adding in a whole other database target. You can either add this to your own database or you can make a new one. And Vuforia will work with multiple databases. It's not a big deal. Alright, going back into here. So into Unity, on our image target, we want to actually place that stuff like here so it uses that. So we need to import that package. So you go to Assets, Import Package, Custom Package. Once again, it's in your Downloads folder. And it's named whatever you named that calibration target. So I'm going to grab that. And that comes in very fast, and you import that, and then there it is. So then if you notice, if you have your image target selected over here, you can change the database name to calibration target or whatever you named it, and then the specific target you're talking about. This width and height, go ahead and leave alone because that's going to match your 6.25 inches wide to Unity's settings, and that's the width that we put in. And it automatically calculated the aspect ratio. That's what the height is there. All right, and then the last thing on the image target here is you have to, this is very important, you have to check this box here for Enable Extended Tracking. A lot of people miss this, and what this allows the HoloLens to do is use its spatial mapping tracking after it doesn't see the picture anymore, or after the cameras don't see the target anymore, which is quite nice. Okay, so that's in there. And then now we have to go back to our AR camera, and then where it says Open Vuforia Configuration, click that, and we're back to where we put that license key in. And then over here on the right, you need to see where it says Data Sets. Check this box to load the database, and then activate it on basically on recognition. So those two check boxes there. All right. Now, since we're working with the HoloLens, we need to set up this main camera to like kind of work as our HoloLens camera. This isn't that important, but I do it. I just set the transform to 0. So I just right click on it, say reset, puts it right in the center. And then I change the gizmos to be smaller just so they don't get in my way. And then we kind of zoom in on that. So now we have kind of everything in the center here. We have our AR target here, and then our HoloLens camera right there. It's not a big deal that they're placed exactly on top of one another. I just do that for organizational purposes. But anyway, this main camera needs to be set up like a HoloLens camera. So we have to go here to camera settings, change this to a solid color, and then we need to change the solid color to be black, because with the HoloLens, black is transparent, meaning we don't want to see anything unless we're actually rendering real things in the environment. Alright, so then the AR camera now represents a rival camera in the scene, so we need to make sure it's not being used as our camera, but the HoloLens camera is. So I'm just going to take our main camera and drag it into this field called Central Point Anchor, and that's again on AR camera. And once you put that in there, the Vuforia system knows to use that camera's transform as its camera. Okay, so anything that you put into your scene now that you actually want to be rendered and tracked needs to actually become a child of image target. And we're going to start with our calibration. Okay, so going back to assets under AR calibration, under prefabs, I've got a thing here called calibration marks. Now if you drag this into the scene, into your hierarchy, you'll see it's pretty big and around your image target. What we want these to do is line up with the image target itself. So I'm going to scale it, so I'm just going to select the main object there, hit R, and then use the middle block to scale it down. So that's pretty good. These don't have to be dead on accurate to the image target. These are really just to represent to you that your image target is calibrated, meaning you're going to know when you have the HoloLens on that this thing is flush with the wall or floor or whatever ceiling wherever you got your image target attached to. Like the demo I showed you, I have it up above my door. Alright, so this line here is different from the corners because this is supposed to represent the top of the image. Now I know this is correct because I built this, but if by accident you do it wrong, and let's say it's like this, all you'll have to do when you look through the HoloLens, if this shows up, say like on the wrong side, all you have to do is come back in and rotate it and try it again. So you just want to make sure that stays at the top. That way you'll know later. Vuforia for some reason now doesn't render the texture map of the image target on here. Or maybe it's because this one's so small, but anyway, I need to know what the top of it is. Alright, so that calibration mark is placed exactly how I want it, so now I need to make sure it gets augmented and attached to that image target. So I'm going to drag it on top of image target so that it becomes a child of it. Okay? Alright, so now we're just going to test this image target with these bounding boxes just to make sure those line up. So then we're going to set our Unity project settings to build for the HoloLens. So this is basically the same as it's always been if you've built for the HoloLens. So I'm just going to go through that real quick here. And then I also subscribe to the recommendation from Microsoft to set my rendering quality to fastest. I know that's not required, but I do it. It seems to work pretty well. Alright, so now I'm going to go ahead and hit build. Oops, I got to add my scene. Add open scene. Build. I'm going to make a new folder above assets and call it app, because that's what the Microsoft tutorials said, and that's what everybody seems to do. So I'm just going to do that. So I'll fast forward for the compiling process here. Okay, so the app is compiled from Unity. Now I'm going to compile from Visual Studio 2017. Setting my Visual Studio 2017 settings up. Now I'm building from Visual Studio over to the HoloLens.
Okay, so I've got the HoloLens on here, and it's been compiled. And if I take my image target and put it in front of the HoloLens, you can see that it goes ahead and tracks the image target. So what you want to do is probably cut this and put this up on the wall. And I want to give you some advice here. So, like, this thing, yeah, you can just kind of plop it on the wall where you want, but it's important that this stays where you place it. So, as you can see, I put mine up over my door, and that's on purpose because we're going to have to scan this room with the HoloLens here in a minute, and I need to find a spot that in the 3D scan of the room, which is going to be really noisy, meaning it's not going to be flat and it's not going to have good edges. I need to find a space that I know where I'm going to be able to look at the image, the 3D scan, and reference a good spot that I can match sort of by eyeball the 3D scan and my image target to it. And I know that this door is going to have a hole that's going to end like a right angle, and I know that this door will be in the scan. But if I just put this at the top right of the door, it's in an easy accessible place that I can see, and it's something I can easily find in the 3D model. So then the idea is anything I build for my office with the HoloLens from here on out, I could just, if it gets off calibrated, I can just look at that and then look away, and everything should stay where it should. Okay?
Okay, and like I said before, this top mark here needs to be at the top of your image target. So if it's not, just take this whole thing and rotate it by like 90 or 180 to match, and then just keep recompiling it until this mark is at the top, because you're going to need that for reference when you place it with the spatial map. Alright, so if you've never done a spatial map before, I'm going to show you how to do that right now. So I'm dialed into the HoloLens developer portal, which is just a website that's hosted off of the device I'm using right now. Alright, so then what I'm going to do is go to this button on the left that says 3D view, and I'll maximize this so you can see what's going on. And it just it shows you your tracking frustum, your two stereoscopic cameras here, and down here at the bottom you can say update. And then what this does is it shows you the cached information that your HoloLens has built in. Okay, so mine's already mapped my office, and if yours doesn't, like whatever space you're trying to work on, you need to take the HoloLens with a laptop, dial into the developer portal to the spot that you want to actually build your app for. Okay, and then make sure you've already taped your image target, your calibration marker up somewhere, and then get started. And I guess it doesn't matter if that's placed there yet, but you need to have in mind where you want to put it. So again, mine's been mapped here, and I'm going to zoom in. If you look, oh shoot, I guess over here above my door is about right where it's going to be there. Okay, so now if yours is incomplete, what you want to do is keep looking around your actual room with the HoloLens on, giving it more information, and keep hitting update, and you'll see it build out, everything that's there. Okay, so mine's done here, and I'm going to go ahead and hit this button here. It says save, and that saves out an OBJ file down here. Okay, so spatial mapping, mine says 1 because it's the second one I've downloaded today, but that's alright. Alright, and that's all you got to do. That's how you spatial map the room. Okay, so now we have our spatial map, and let's go ahead and match our AR target to where it should be above the door on the spatial map. So what I want to do is bring that in as an asset, but just to keep things organized, I'm going to create a folder called spatial map. Okay, and then right click in there and import new asset, and it should be in your downloads folder if you downloaded it off the developer portal. Mine's going to be this one, and it takes a little while because it is a mesh for Unity to cache it and sort of convert it behind the scenes to the version that a version that it can use. And then now we've got it. It's important that you don't just drag it in your scene arbitrarily, so I'm going to drag mine into the hierarchy. So from that point of view, I'm going to look at a top-down view here, and I'm going to switch to isometric. So if you see below the 3D tree here, if you hit this button or this text here, it'll switch to isometric view. That'll help you to sort of place things. And I'm going to look at it from a few different angles. So you can see there's my door right there. And really, this image target needs to be placed like it is in my office here, up above my door to the top right. Now, just for you, just pick the spot that you placed it. if you switch back to perspective view and sort of tumble around, you'll be able to find it because you'll recognize things. Like I can recognize that this is probably my desk here with my monitors, even though it looks like a bunch of just jumbled up nothing. And that's definitely my doorway right there. So see how that's recognizable? So those sorts of things are easy to help you sort of co-locate where you want to put your image target. I know this is not precise, and other methods need to be developed. Maybe I'll have another tutorial in the future for more precise mapping or calibration, but this is going to get you pretty close. So now I'm going to put the image target right there. So again, going back to isometric view, looking from the top down, let's just start kind of doing this right. So I'm going to move it over and zoom into it. So now I know that my doorway is here on the right side, so I need to rotate this whole thing. So I think it's rotating on the y-axis, correct? And I need to rotate it this way. So I'm going to do a 90, just type that in. Okay, so now if I look at it from the side view, I need to rotate this sort of up, so that's on the x-axis. So that one is this axis, so I'm going to change that to -90. And then if I look at it from the front view, you can see it's placed there just about correctly, but let's put it up above the door now. Again, this is arbitrary placement, so top-down view. We're going to go here, and you can see it needs to rotate differently. And now for sort of the non-90 degree rotations, I'm switching back to perspective view, and I'm going to press F on the keyboard. That zooms me right into it. And I'm going to get this so it's right up against the wall here, and then I'm going to start matching this rotation to this unflat wall. Yeah, so rotate. Again, this is just not that precise. Okay, that is just about close enough. Maybe over a little bit. All right, and even the spatial map is not that precise, you know. So this is basically not that useful for precise location, but this is going to get us started. All right, so now that this is located, I'm going to take the spatial map, the entire object, and make it a child of image target. So now it's actually going to be augmented, and then to make the shader kind of work a little bit better, because this one's actually calculating lighting features. We don't need that. Twirl open your spatial map, twirl open default, and go to find the objects that actually have meshes associated with them. So, or I'm sorry, mesh renderers, and then we're going to change their shader. So I'm going to go down on the standard shader and change it to VR spatial mapping wireframe. Later on, you know, you might actually want to use this with the occlusion once it's calibrated, because occlusion, what that actually will do is block objects from being seen. If you notice, I sort of let's see here. If I do this, something in the room like the light fixture is blocking my image target there. So that's kind of cool, so that you can get occlusion features. But that's probably a topic for another day. Today we're focused really about calibration. So this wireframe view is kind of weird, because as you get further away from it, it changes color. It's based on your placement of your camera. But now that this is a child of image target, this whole thing will get augmented. So now I'm going to compile this for our HoloLens, and we'll check it out, make sure it works.
Okay, so I've got the app running now, and if I look at this image target up here, you can see there it goes, it pops in. So I had to walk closer to it, and then now when I look away from it, the spatial mapping sort of takes over. Now I've done this a few times, so I've gotten good on my placement to match that up to the doorway, and you can see the spatial map sort of matches up pretty well with that. And the rest of the room seems to be okay. And one thing that's a telltale sign that there's a problem is like this lamp here. It doesn't quite match up to the edge here, but that's okay. You can just constantly go back into Unity and change the placement of these things so that they actually line up. All right, so I'm going to continue on and assume my placement works.
Okay, so again, if your spatial map didn't line up with your real world, consider that this is your anchor point, your image target object, and double check that, you know, maybe your rotation might be just need to be tweaked just very slightly. And the only way you're going to be able to do this easily is you're going to have to go back into image target, unparent child or spatial mapping, so pull that out, and then grab your image target and make the tweaks that you need to make. So like for me, this lamp wasn't really quite lining up here, and then, you know, I might want to just do a little bit of a rotation. And this takes some spatial intelligence, meaning your mind has to work sort of in 3D, considering that this is the anchor and you're moving everything. So I'm actually going to leave mine alone. I think it's good enough. I'm going to stick with it. and move forward. So I want to just show you this in practice. So like how you would actually use this. What I'm going to do is put that cube on my desk. So going back down here, I know that this is my desk down here. It's hard to see with this sort of shader, so you can actually turn that old shader back on if you wanted to, which is just standard shader. Okay, so it's like lit. There we go. Oops. All right. So now let's go ahead and put a cube on my desk somewhere here. So just go to Game Object, 3D Object, Cube. That thing is huge, so I'm going to make it smaller. 0.1, 0.1, and 0.1. And we're going to go ahead and move that down to the desk there. It's tricky. Yeah, the better your spatial map is, the better it's going to turn out. Then you can actually reference items. Okay, that looks like my desk surface right there just by tumbling, and I can see underneath it. Alright, so then I'm going to move this over, just place it right there. Okay, I'm going to go back to my spatial map and reset. Actually, I don't even need my spatial map anymore because it's just a reference at this point. So you can set the shader to whatever you want it to be, but it's important now that you either turn it off, or if you're going to keep it in there as an occlusion mesh, then you go to VR spatial mapping occlusion. I'm not going to do that. I don't care about occlusion right now. Maybe later, but I consider this to be a very inefficient mesh, meaning I would like, for occlusion, I might take this in another program and clean it up so it's not so heavy in polygons, and bring it back in and use it as an occlusion mesh. But for right now, I'm just going to uncheck it up here and make it inactive. And we've used it as reference, so I know the image target matches my wall above my desk, and I know that this cube matches where my desk is. So I'm going to compile now and just double check that this cube ends up on my desk. Okay, real quick before I compile, I made a mistake here. I need the cube to actually be as a child of the image target. This is very important, so anything that you do in your work that needs to be rendered as an augmented object, some graphic or whatever, you have to make it a child of image target, okay, for this to function. So now I'll go ahead and compile and double check that this cube actually shows up on my desk.
Okay, so I've got the HoloLens on and there's not a cube on my desk, but we need to calibrate. So let me go ahead and look up at the calibration marker. Okay, the green lines show up and they appear to be in my stereoscopic vision right on there on the wall where they should be. So now let's look down sort of at my desk. I don't see it yet. Let's look at it again. So it's important to give it a little bit of time. And then I look, there it is right there. Okay, so the cube showed up. So now the spatial mapping should take over. You know, it's pretty important to kind of initially give it some time to look and find the target and then see the room a little bit so that Vuforia can do its thing and the HoloLens can do its thing. And then you have a calibrated room space that you can now do augmented reality anywhere. You know, I could augment the wiring behind the drop ceiling here, below the floor, through the walls, if I needed to. I could do games. I could basically design a game for this room. But the point is, we have a tracked space that can be calibrated over and over again. So I could build out an app that could run, maybe that takes a long time, right? And the HoloLens may get the graphics sort of off kilter, off calibration. So then it's like, okay, in the middle of the app, just walk over here, take a look, everything should get realigned. I don't have to air tap it or anything like that. Just look at the target, wait till the green lines sort of get lined up like that, it's just snapped, and then look, there it is. So then that becomes your anchor point, okay, for everything. All right, thank you for watching this tutorial, and good luck in the future augmenting and creating quote-unquote holograms or volumetric graphics. So thank you. Bye-bye.